Here we go. Let's expand this binomial using the binomial theorem. Binomial theorem I've got written right here. And then another thing that's going to be useful for this expansion is Pascal's triangle. So Pascal's triangle helps us figure out combinations. So if I wanted to do 4, choose 3, I would go 0, 1, 2, 3, 4, and then over 0, 1, 2, 3. And the answer to that would be 4. So this is super helpful. It's not super helpful when we have like higher n values, but I'm going to utilize it when I expand this binomial because to me, it's way easier than going to my calculator, having to go to math, probability, and then type it all in. So I really like to utilize Pascal's triangle whenever I can. We can build this, right? We start with these 3 1s, and then to get the diagonals, we just have to add. So 1 plus 1 would give us 2, 1 plus 2 would give us 3, 3 plus 3 gives us 6, right? And this works for every single diagonal. All right, let's expand. So when we're doing this, our terms, our a in this case is going to be x squared. Our b is going to be negative 2y. We want to make sure we bring the negative sign with. Our n is going to be 3. So we don't necessarily need to plug it into the summation notation, but we have to know that, okay, we're going to start with k equaling 0, and then we're going to keep increasing that as we go throughout the sum. So I'm going to start with n being 3, right? It will always be. And then k, 0. A is x squared. And I'm going to put that to the n minus k power. Well, 3 minus 0 is just 3. Times negative 2y to the 0. Right? Technically, you don't have to write this because it's just 1. You don't have to write this part because it's also just 1, right? Anything to the 0 power is just 1. But I like to put it because it helps me to keep organized as I go through this expansion. Next term, k now equals 1. So we got 3, choose 1, x squared to the 3 minus 1 power, which is 2, times negative 2y to the first power. Right? Notice that our powers here, this 2 and 1, this 3 and 0, they'll always add to 3. So if I get lost, that's what I always look at. All right, now I'm on to 3, choose 2. X squared to the first power times negative 2y to the second. Still adds 3. Oh no, am I going to run out of room? I'll squeeze it in there. Plus 3, choose 3, times x squared to the 0 power times negative 2y. I'm going to make it to the third power. Nice. Now we just got to get to simplifying. Well, when I'm looking at n equals 3, with Pascal's triangle, it always starts with 0. So this is going to be n equals 0, n equals 1, 2, 3. So we're looking at this row right here. So 3 choose 0, well, that's just 1. X squared to the third power is x to the sixth, and negative 2y to the 0 is just 1, so I'm not going to write it. Plus 3 choose 1, well, that's going to be 3 times x to the fourth times negative 2y. 3 choose 2 is also 3, right? Just moving down that row of Pascal's triangle. X squared to the first is just x squared. Negative 2y squared is 4y to the second. 3 choose 3 is 1. X to the squared to the 0 is 1. And then negative 2y to the third power is going to be negative 8y cubed. That's ugly. Here we go. Simplify one more time. X to the sixth plus 3 times negative 2, actually minus 6. X to the fourth, y. 3 times 4, we got 12 x squared y squared plus minus negative 8y cubed. Look at that beautiful polynomial.